Hugh, thanks very much for allowing me to come and see you today. And thank you very much also for the custom. I know you bought this CNC router, and we've had quite a discussion this morning about the facilities in the school and in this subject, design technology. Just give me the reasons why you wanted this machine.
Well, CNC, computer numerically controlled machines, are in industry. They're everywhere. And we have a CNC laser cutter, and we were using that a lot, but it can only cut thin materials.
Right.
So we wanted another option. But I also wanted something that was industrial standard. So the students get used to using these industrial standard pieces of equipment so that they're aware of what's out there and they can use it. Of course, it won't remove or replace the training that they'll get with industry, because that will be specific to those machines. But they'll have a basic understanding. So although they won't be programming the machine, they do design the piece of work that is then sent to the router. But I want them used to setting it up.
Well, this machine is actually an industrial size machine, and we do sell it to industry. It's a British-made machine, which is what I like about selling it. It's unique to HME. And yes, so a lot of one-man operatives are doing a lot of creative work with, particularly when you go into hotels and pubs and that sort of thing. You see the signs on the wall,
yes, yeah,
all done on these machines and in lots of different woods.
Oh yes, and that's what I like about it. And I think ultimately we don't know what we're going to use it yet for, because we haven't designed it yet, or we haven't discovered it yet. And there's a lot of new materials out there that we'll probably start to use on it.
Lovely.
What I really liked though was how it was built on site, and the engineer was brilliant because he assembled it, he talked us through the assembly of it, and he talked us through the training on the software.
Lovely.
So he did a grand job.
Good, lovely. Thank you very much. Right, Hugh, what a backdrop to talk about 3D printing. You've got a project here for Year 7, the Bubble Project. Just talk to me about that briefly, if you may.
Well, what I wanted was something that allowed the students to use computer-aided design to make a real-life product.
Yes.
And the challenge is, at the end of the project, to take it home and try and tell their parents that they bought it from the shop to see if the parents would take it in.
Oh, brilliant, what a challenge.
But the thing I like about it is it looks real at the end of it, and they've learned so many different things about what is on packaging, how packaging looks. And, you know, we use some computer-aided design in there, the laser cutting for the wand.
Yes.
What I'd really like to be able to do is 3D print them.
Right.
So that's why we've purchased these 3D printers.
Well, this is a British design 3D printer. It's assembled overseas, I know, a little bit like the James Dyson with his vacuum cleaners. Yeah. But tell me about this, because I know so many people buy 3D printers, download something from the internet and produce it. But you're different, aren't you?
I know. It is easy to download from the various websites to produce products, but ultimately what we want to be able to do is get this into the GCSE.
Right.
So students might design it in Onshape, a cloud-based 3D software.
Right.
And you know, they can be designing clamps, they can be designing units for it.
So what's this clamp for?
Well, this clamp is designed for mounting bike handlebars, and then this unit clamps on with it, so you can put more lamps on the front of your bike, so it makes it more noticeable at night.
Right.
And this is the sort of thing that we want students to be creating, rather than just copying somebody else's work.
Absolutely. And what about this device?
Well, that one's a nozzle for a bottle, and we do water-powered cars, and where you put compressed air into a normal PET bottle with a small amount of water in. And what we were testing there is how much power and the different sizes of nozzles, the apertures of the nozzles would give to the car.
Brilliant.
3D printing allows us to make different ones, you know, just altering that diameter in the middle fairly quickly.
Yes.
So you can then experiment, test. And again, this comes back to the same sort of thing that we do in science, where they do an experiment, and they try out the different variables and they try out the different
Right.
changes, and then they work out which is the best design.
Optimum
And
result, yes.
Ultimately, this is science in action.
It is.
And the 3D printers allow us to do that because they allow us to make things at a better quality than we would, or cases better quality than we could if we were vacuum forming.
Yes, yes.
So one of the projects I'd like to do in the forthcoming year is an emergency mobile phone charger.
Yes.
Where they disassemble one, use the innards of a recharging socket for the cars, and solder on a 9-volt battery lead, and then make the case. So that's not something they can download from the internet.
No.
Because we'll be able to see their designs in Onshape and then send them to the 3D printer to make.
Okay, so will you allow me to come back and have a look at the finished product next year?
Love you to come
Brilliant.
back and have a look
Thank
at
you
the
so
project.
much.
And I'll still challenge you to work out who's met their target and who hasn't.
Right, okay, thank you.